Okay, having completed the previous video, we know roughly what's going to happen, but this time I'll explain. The purpose of this demonstration is primarily to demonstrate the properties of the interface between the planner and the plan manager. The plan manager is a logic labeled finite state machine that runs on the robot. The planner itself is a executable which runs as a normal process. So what we're going to do is we're going to start the robot. You saw the lights go on and so forth. The whiskers became red to indicate that they're in use. The status is displayed here in the bottom of WebBots. And the robot's not moving because it doesn't have a plan. So we'll run the planner, and as you can see, a plan has been transferred. And what we're going to do now is we're going to terminate the planner and see what the robot does. It'll discover this unknown obstacle because in the layout of the grid, this is the shortest path without any other knowledge. So that's where it's going to go. So okay, it's about to discover the obstacle, in which case it returns to the previous intersection that it was at, and it places a request for a new plan. The method of doing that is basically it's updating its state on the whiteboard. We can see here from the logic label finite state machine's status messages that it's failing its goal. So we'll run the planner. That generates a new plan, and we'll stop it again. Okay. This time it's going to go to this. Well, it's going to discover this obstacle because obviously this is the shortest path from where it was last at. And when it discovers that obstacle, it will of course do exactly the same as before. It'll return to the intersection and request a new plan based on the new information that it has. Okay. The red whiskers, incidentally, are proximity sensors available on the epuck. Okay, so there we go. So it's now looking for, it's waiting for a new plan. So we'll run the planner. It generates a new plan, and off it goes. And if you saw the previous video, you'll see that it's now going in the direction that going around, and we'll eventually get to the goal, which is where the soccer ball is. One thing to take note is that the initial conditions in this run are a clean whiteboard. That is, it was instantiated, the shared memory that's being used was instantiated from scratch, and therefore everything is initialized to its default constructor settings, which in most cases is a 0. So there you go, the plan is complete. So what we'll do now is we're going to reset, we're going to stop the behavior, We're going to reset the simulation, and from the previous run we've now remembered what the obstacles are, so we're going to run again. The planner is offline, so we should expect the epuck to be sitting here waiting as it is there. Okay, so once again we'll run the planner. It generates a plan. You'll see that the plan is different from last time, and that's of course because we know that the path down to the bottom of the screen here in WebBots is not really the best option, and so it plans the shortest path, which is going to go around the top, the same as it was in the last video. In the first video, the planner was running the whole time, so it was calculating, replanning dynamically. I was updating the initial location of the robot to wherever it was at the time that it requested the plan. I was inserting atoms to represent the obstacles that were discovered, and that was all done without the plan exiting or terminating its process. So that was a little bit different this time, where we were stopping and starting the planner to demonstrate the other aspects of the protocol and the interface. So this time the whiteboard is not clean. All of the information that was, the state that was current at the end of the simulation is what the whiteboard had in its shared memory. So in running this run, we can see that the existing information doesn't impact on the performance of the next. It's still able to succeed. So there you go. Mission accomplished. Thank you for watching. I hope that was informative.